Now practice more than 1.5 lakhs questions to crack JEE NEET on PracBee practice app. Download now.
Now, see, suppose there is a body. It is moving with some velocity v. Let's say that this velocity is constant. After some time, let's say that this is t equals to 0. This is uniform circular motion. Isn't it? If it is uniform circular motion, that means at, that is tangential acceleration, which is dv by dt is 0.
at, हाँ, रेडियली होएगा पर कांस्टेंट,
बट रेडियली होगा. मान लेते हैं कि टाइम t पे ये पहुंच गया somewhere here.
वेट, बिकॉज रेडियल एक्सेलरेशन की भी डायरेक्शन हर टाइम बदल रही है तो वो भी कांस्टेंट नहीं आएगी ना.
रेडियल एक्सेलरेशन का मैग्नीट्यूड कांस्टेंट होगा इसमें, बट डायरेक्शन कांस्टेंट नहीं होगा. Fine. So v is constant. I can also say omega is constant if v is constant. So I can say if this has covered an angle theta, theta can be written as omega t. If r is the radius of this circle, so if I want to draw a position vector r of this particle at instant t, so I can say that position vector is r cos omega t I cap r sin omega t j cap. This derivation, by the way, is important. समझ में आया रशीद? So if I
k cap ना, sorry,
j cap, this is y axis.
Right.
So dr by dt is called as velocity. See, and circular motion is the chapter where velocity, speed, all these have their original meaning. You can't confuse between them.
Right.
dr by dt. So this is r omega. Fine. Before I do dr by dt, I'll like to tell you one thing, that this can be written as r cos omega t I cap sin omega t j cap. Fine. This term is a unit vector. Let's call it as er. What is unit vector? Whose magnitude is 1. So its magnitude will be cos square omega t plus sin square omega t. That will be 1.
Right.
So I can write r as r into er unit vector. And this er unit vector, what is the direction? The direction is in this direction. Direction of r vector. That is along the radius. Fine. Now I differentiate dr by dt. So this becomes r inside bracket omega minus sin omega t I cap omega cos omega t j cap. So this is minus omega r sin omega t I cap cos omega t j cap. And this is velocity. So I can say velocity is, Rashid, minus omega r into another unit vector et. That is a unit vector which is tangential. So you can ask me, how do we know? How do I know that it is tangential? So I know that er dot et will be 0. Dot product of two perpendicular vector is 0.
Right.
Fine. So this is in this direction et. So I have proved that velocity is always tangential.
सर वो माइनस होएगा sin omega t I minus cos omega t.
Sorry. Let's. ठीक है. समझ में आया गुरशीष यहाँ तक? Fine. So magnitude of velocity is called as speed. This is velocity, by the way. This is speed. Speed is omega r. ठीक है? Now if I differentiate velocity again, so dv by dt ये हो जाएगा ओमेगा स्क्वायर आर, साइन का डिफरेंशिएशन माइनस कॉस ओमेगा टी आई कैप माइनस साइन ओमेगा टी जे कैप.
Okay.
So dv by dt is like minus omega square r er.
Right.
So radial acceleration हमने प्रूव कर दिया कि जो radial acceleration होगा dv by dt, this will be towards center. So we have total acceleration. So total acceleration is radial acceleration plus tangential acceleration vectors.